Our solar system is a place of immense wonder. It teems with planets, moons, and countless smaller objects, each with its own story to tell. Among these celestial bodies, Jupiter stands out as a true giant, orbited by over 80 moons. One such moon, a tiny world with a curious story, is Themisto. Discovered in 1975, Themisto is a solitary world, rediscovered in 2000. Its journey around Jupiter is a lonely one, far different from the intricate dances of the inner moons. Themisto's path is highly inclined and eccentric, taking it far above and below Jupiter's clouds. This solitary journey makes Themisto a challenging but tantalizing target for observation. Themisto's story began in 1975, when it was first spotted by astronomers Charles Cowell and Elizabeth Romer. Using photographic plates taken at the Palomar Observatory, they detected a faint object moving against the backdrop of distant stars. However, due to the limitations of the technology at the time, they were only able to make a handful of observations before Themisto disappeared from view. Then, in 2000, a team of astronomers led by Scott Shepard and David Jewett, using the powerful Canada-France-Hawaii telescope, rediscovered the elusive moon. This time, equipped with more advanced imaging techniques and digital detectors, they were able to capture detailed images of Themisto, confirming its existence beyond doubt. The rediscovery sent ripples of excitement through the astronomical community, reawakening interest in this tiny world that had been lost for so long. Themisto's journey around Jupiter is a solitary one, far different from the intricate dances of the inner moons. Unlike the Galilean moons, Themisto's path is highly inclined and eccentric, taking it far above and below Jupiter's clouds. This unusual orbit sets it apart, suggesting a unique history. Imagine Jupiter as a stage, with its moons as dancers performing a celestial ballet. The Galilean moons are the principal dancers, gliding in near-perfect circles. Themisto, however, is a lone figure, its movements erratic and unpredictable. It dashes in close to Jupiter, then swings far out, crossing other moons' paths. This solitary dance is a result of Themisto's unique orbital characteristics. Its high inclination means it orbits at a steep angle, like a moth circling a lamppost. Its high eccentricity means its orbit is elongated, like a stretched-out rubber band. These characteristics suggest Themisto may have been captured by Jupiter's gravity. Themisto's unusual orbit makes it a valuable target for study. Understanding Themisto helps us learn about planetary dynamics and evolution. Themisto's path may hold clues to the early solar system's dynamics. As we delve deeper into the study of Themisto, we begin to unravel the mysteries surrounding this solitary moon. Its size, composition, and potential for harboring water ice are all subjects of ongoing scientific investigation. By piecing together clues from telescopic observations and models, we hope to understand Themisto's place in the Jovian system. One of the primary challenges in studying Themisto is its small size and faintness. With an estimated diameter of only about 8 kilometers, it is a mere speck of light even through the most powerful telescopes. This makes it incredibly difficult to obtain detailed images of its surface or determine its precise shape and composition. However, astronomers can infer some of its properties by analyzing how it reflects sunlight. Based on these observations, Themisto appears to be a dark, rocky body, similar in composition to some of the asteroids that populate the outer regions of the asteroid belt. The presence of water ice on Themisto is of particular interest to scientists. Water is a key ingredient for life as we know it, and its presence on other celestial bodies has profound implications for our understanding of the potential habitability of the solar system. While Themisto's small size and distance from the Sun make it unlikely to harbor liquid water on its surface, it is possible that water ice could exist in its subsurface, protected from the harsh radiation of space. Future missions equipped with more sensitive instruments could potentially detect the presence of water ice on Themisto, shedding light on its formation and evolution. The study of Themisto and other small irregular moons is crucial to our understanding of the formation and evolution of planetary systems. These objects are believed to be remnants from the early solar system, preserving clues about the conditions that existed billions of years ago. By studying their orbits, compositions, and surface features, we can gain insights into the processes that led to the formation of the planets and their moons, and the complex gravitational interactions that have shaped their destinies over time. In the vast expanse of our solar system, size is relative. Jupiter, a colossal giant, dwarfs our planet many times over. Even its largest moons like Ganymede and Callisto are comparable in size to Mercury. Themisto, a tiny dancer in this cosmic ballet, is a mere speck compared to its larger companions. Its diminutive size, however, does not make it any less intriguing. Astronomers estimate Themisto's diameter to be approximately 8 kilometers. Imagine shrinking our planet to the size of a small city. Themisto's entire surface area would fit comfortably within London. Unveiling the composition of a celestial body like Themisto, especially one so small and distant, can seem like an insurmountable task. We cannot simply scoop up a sample and analyze it in a laboratory. Instead, astronomers rely on a combination of observational techniques and theoretical models to deduce the makeup of these distant worlds. One of the primary tools in our arsenal is spectroscopy, a technique that involves analyzing the light reflected from an object. Just like a prism separates sunlight into its constituent colors, a spectrograph can spread out the light from Themisto, revealing telltale signatures of different elements and compounds present on its surface. These signatures appear as dark or bright lines at specific wavelengths in the spectrum, each corresponding to the unique way in which different substances interact with light. Based on spectroscopic observations, Themisto appears to have a dark reddish surface, similar in color and composition to some of the asteroids found in the outer regions of the asteroid belt, beyond the orbit of Mars. This suggests that Themisto might be a captured asteroid, a relic from the early solar system that was gravitationally snagged by Jupiter's powerful pull and forced into its current eccentric orbit. The reddish hue of Themisto's surface is likely due to the presence of organic molecules, complex carbon-based compounds that are ubiquitous in the outer solar system. These molecules are thought to have formed in the cold, dark depths of the protosolar nebula, the swirling cloud of gas and dust from which our solar system emerged billions of years ago. By studying the composition of objects like Themisto, astronomers hope to gain insights into the conditions that prevailed in the early solar system and the processes that led to the formation of planets, moons, and other celestial bodies. Each piece of data, like a puzzle piece, helps us construct a more complete and detailed picture of our cosmic origins. Gazing at the moon on a clear night, we can't help but be captivated by its intricate tapestry of craters, mountains, and vast plains, each feature telling a story of cosmic collisions and geological upheaval. Themisto, a small moon in Jupiter's magnetosphere, is sculpted by billions of years of impacts. Unlike larger moons, it's likely geologically dead. Its surface is pockmarked by relentless bombardment. These impacts provide clues to the history and evolution of the Jovian system. Future missions could reveal the secrets beneath its scarred surface. Despite the challenges, scientists are eager to learn more about Themisto's internal structure. Based on its estimated density, Themisto is thought to be composed primarily of rock and ice. One intriguing possibility is that Themisto could harbor a subsurface ocean of liquid water. Internal heating from Jupiter's gravity could melt some of the ice, creating a hidden ocean. Detecting a subsurface ocean would require sophisticated instruments and dedicated missions. By studying Themisto, we can gain a deeper understanding of the diversity of worlds in our solar system. Themisto's journey around Jupiter is a solitary ballet, a stark contrast to its larger siblings. While the Galilean moons waltz around Jupiter's equator, Themisto's path is highly inclined and eccentric. This unique path suggests a past shrouded in mystery, possibly a captured object. Themisto's inclination is a significant 43 degrees, cutting a path of its own. Its journey is not a simple circle but an ellipse, a stretched-out oval. Understanding these orbital characteristics is key to unraveling the mysteries of Themisto's origin. Themisto's inclined orbit sets it on a roller coaster ride around Jupiter. This inclination, a dramatic tilt of 43 degrees, paints a picture of a moon out of sync with its siblings. Themisto's orbit lifts it high above Jupiter's equatorial plane, offering a unique vantage point. This high inclination has profound implications for Themisto's journey. Unlike the Galilean moons, Themisto's tilted path subjects it to varying gravitational tugs. This isolation makes Themisto less susceptible to collisions, potentially preserving its pristine surface. Themisto's journey around Jupiter is an elongated, elliptical dance. This eccentricity is key to understanding Themisto's unique story and potential origins. At its closest approach, Themisto ventures within approximately 4.6 million kilometers of Jupiter. This close encounter subjects the moon to intense tidal forces, potentially generating heat within its core. As Themisto swings away from Jupiter, the gravitational grip loosens, and the moon enters a more serene environment. The high eccentricity of Themisto's orbit raises intriguing questions about its origins. Themisto's solitary dance around Jupiter is influenced by the gravitational pull of the gas giant and its moons. This intricate gravitational ballet shapes Themisto's orbit and provides insights into planetary systems. While Jupiter's gravity is the dominant player, the combined influence of the other Jovian moons can have a significant effect over time. These gravitational interactions can lead to orbital migration, where a moon's orbit gradually shifts. Understanding these interactions is crucial for reconstructing the history of the Jovian system. By studying Themisto's orbit, astronomers can gain insights into the masses and distributions of other Jovian moons. In the vast expanse of our solar system, Jupiter reigns supreme, orbited by a diverse family of moons. Among these celestial siblings, Themisto stands out for its solitary dance in the outer reaches of the Jovian system. To appreciate Themisto's uniqueness, we must compare it with its more famous siblings. The Galilean moons, Io, Europa, Ganymede, and Callisto, are the eldest, each a world unto itself. Further out we find the smaller, irregular moons, a motley crew of captured asteroids. Themisto's small size and highly inclined orbit hint at a past shrouded in mystery. One of the most striking differences between Themisto and its Jovian siblings is their size. While the Galilean moons rival Mercury in diameter, Themisto is a diminutive world. This vast difference in scale reflects the different formation mechanisms and evolutionary paths. Ganymede, with a diameter of over 5,200 kilometers, boasts its own magnetic field. Themisto, measuring a mere 8 kilometers across, is likely a cold, inert world. The smaller, irregular moons of Jupiter likely represent a diverse collection of captured objects. The Jovian system is a celestial ballet, a mesmerizing dance of moons orbiting their colossal parent. The regular moons orbit in a relatively flat plane around Jupiter's equator. The irregular moons exhibit a much wider range of orbital characteristics. Themisto, with its highly inclined and eccentric orbit, falls within the irregular moon category. Its orbital characteristics suggest a past different from its regular siblings. The irregular moons provide valuable clues to the early history of the solar system. The stark contrast between the regular and irregular moons of Jupiter hints at two distinct formation scenarios, each painting a different picture of the early solar system and the processes that gave rise to the diverse array of planetary systems we observe today. Imagine a swirling cloud of gas and dust, a circumplanetary disk surrounding the young Jupiter, much like the protoplanetary disk from which our solar system formed. Within this disk, particles collide, stick together, and gradually grow into larger and larger objects. This process, known as accretion, is thought to have given rise to the regular moons, including the Galilean moons, their orbits reflecting the orderly nature of their formation within Jupiter's gravitational grasp. Now, imagine a cosmic shooting gallery with Jupiter acting as a gravitational magnet, attracting and capturing objects from its surroundings. These captured objects, remnants from the early solar system, could include asteroids, comets, and even planetesimals, the building blocks of planets. Their orbits, often highly inclined and eccentric, reflect their chaotic capture and subsequent gravitational interactions with Jupiter and its other moons. Themisto, with its irregular orbit, is likely a member of this captured family, its presence a testament to the dynamic and often violent nature of planetary system formation. The irregular moons, like puzzle pieces scattered across the solar system, provide valuable clues to the conditions that prevailed in the early solar system, the distribution of material, and the gravitational interactions that shape the architecture of planetary systems. Themisto, a keyhole to the past. Themisto, a small moon of Jupiter, is a celestial time capsule. It preserves clues from the early solar system, offering insights into our cosmic past. Studying Themisto is like cosmic archaeology, revealing the history of our solar system. Among the many scientific questions surrounding Themisto, one stands out with particular intrigue. Could this tiny moon harbor water ice beneath its dark, cratered surface? The presence of water ice on celestial bodies holds profound implications, not only for understanding the evolution of planetary systems, but also for the tantalizing possibility of finding life beyond Earth. Water, as we know, is essential for life as we know it. While Themisto's small size and distance from the Sun make it unlikely to harbor liquid water on its surface, it's conceivable that water ice could exist in its subsurface, protected from the harsh radiation of space. This ice could be a remnant from the early solar system, incorporated into Themisto during its formation, or delivered later through impacts from comets or water-rich asteroids. Detecting water ice on Themisto, however, presents a significant challenge. Direct observation of its surface is limited by its small size and distance from Earth. Instead, scientists must rely on indirect methods to infer the presence of water ice. One promising technique is spectroscopy, which involves analyzing the light reflected from Themisto's surface. Water ice absorbs light at specific wavelengths, creating telltale signatures in the reflected light spectrum that can be detected by sensitive instruments. Another approach is to study Themisto's interaction with Jupiter's magnetic field. Water ice is a poor conductor of electricity, so its presence beneath the surface could influence the way Themisto interacts with Jupiter's powerful magnetosphere. By analyzing these interactions, scientists can gain insights into the moon's subsurface composition and the potential presence of water ice. Discovering water ice on Themisto would be a significant finding, adding to the growing list of celestial bodies in our solar system that harbor this precious resource. It would strengthen the case for future missions to explore these icy worlds in more detail, searching for signs of past or even present life beyond Earth. While telescopic observations from Earth have provided valuable insights into Themisto's orbit and potential composition, a true understanding of this enigmatic moon will require dedicated missions designed to study it up close. Future missions equipped with advanced instruments could unlock the secrets hidden beneath Themisto's surface, revealing its geological history, internal structure, and perhaps even signs of water ice or other intriguing compounds. One of the most promising mission concepts involves a flyby spacecraft equipped with a high-resolution camera, a spectrometer, and a magnetometer. Such a mission could capture detailed images of Themisto's surface, map its composition, and study its interaction with Jupiter's magnetic field. The data collected during a flyby could revolutionize our understanding of this diminutive moon, providing valuable clues to its formation, evolution, and potential for harboring water ice. A more ambitious mission scenario involves a lander that could touch down on Themisto's surface, collecting samples for analysis and deploying instruments to study its subsurface. A lander equipped with a drill could penetrate beneath the surface, searching for evidence of water ice or other volatiles. Analyzing the composition of these subsurface materials could provide insights into the moon's internal structure and the processes that have shaped it over billions of years. Another intriguing possibility is a mission that would deploy a small mobile probe to explore Themisto's surface. Such a probe, similar to the rovers currently exploring Mars, could traverse the moon's terrain, collecting data on its geology, composition, and potential for harboring resources. These future missions, while technologically challenging, hold the key to unlocking the mysteries of Themisto and other small irregular moons in the outer solar system. By venturing to these unexplored worlds, we can gain a deeper understanding of the diversity of celestial objects that populate our cosmic neighborhood and the processes that have shaped their evolution over billions of years. The study of Themisto, though focused on a single, seemingly insignificant moon, extends far beyond the confines of Jupiter's system. It touches upon fundamental questions about the formation and evolution of planetary systems, the distribution of water and other volatiles throughout the solar system, and the potential for life beyond Earth. By unraveling the mysteries of this diminutive world, we gain a broader cosmic perspective, expanding our understanding of our own place in the universe. Imagine standing on a beach, gazing out at the vastness of the ocean. Each grain of sand, though seemingly insignificant on its own, contributes to the immensity of the beach as a whole. Similarly, each celestial object, from the largest stars to the smallest moons, plays a role in the grand tapestry of the cosmos. Themisto, with its irregular orbit, potential for harboring water ice, and connection to the early solar system, reminds us that even the smallest objects can hold valuable clues to the universe's grandest mysteries. By studying these seemingly insignificant worlds, we challenge our assumptions, expand our knowledge, and gain a deeper appreciation for the intricate workings of the cosmos. Furthermore, the study of Themisto and other objects in the outer solar system has implications for the search for extraterrestrial life. The presence of water ice on these distant worlds raises the tantalizing possibility that they could harbor subsurface oceans, potentially habitable environments where life might have arisen. While we have yet to find definitive evidence of life beyond Earth, the exploration of these icy worlds offers one of our best chances of answering this profound question. In the grand scheme of the cosmos, Themisto may seem like a mere footnote, a tiny world orbiting a giant. Yet it is precisely by studying these seemingly insignificant objects that we make the most profound discoveries, expanding our cosmic perspective and deepening our understanding of the universe and our place within it. As we conclude our journey to Themisto, this diminutive moon orbiting the mighty Jupiter, we are reminded that the universe is filled with hidden wonders, each celestial object holding a piece of the cosmic puzzle. Themisto, though small, offers us a unique glimpse into the past, a window into the chaotic early days of our cosmic neighborhood. Its heavily cratered surface serves as a reminder that even the smallest celestial bodies can hold profound secrets. As we continue to explore our solar system and beyond, we must remain open to the unexpected, for it is often in the most unassuming places that we find the most profound truths about our universe.